Hello, my name is Jesse Hunter. I'm a technical marketing engineer at Atmel Corporation. Today I'll be showing you a little bit about our Atmel AVR picoPower microcontrollers. picoPower is really a culmination of years of research that we've put together in low power techniques, low power design. Today we're going to focus on our 4 different variants of microcontrollers. We have the tiny AVR, small packages, very high integration, ADC with differential gain, things like that, a lot into a little package. The Mega AVR is the world's most successful 8-bit microcontroller. It features everything from USB to CAN, lots of timer counters, UARTs, you name it. All that integrated into a single package. The next phase of our AVR microcontrollers is our XMEGA. This really takes performance to the next level. We increase the clock frequency to 32 megahertz. You can run that off the internal RC. A lot of peripherals on this. You'll find 8 UARTs, multiple timer counters. Really takes performance and peripheral mix to the next level. If we move up in the scale, we have our 32-bit AVR UC3 product line. This is our really designed for high power, high performance, low power applications. Really targeting anyone who needs a lot of peripherals in the same mix, but yet have that very low power. So first we'll talk a little bit about the tiny AVR and the mega AVRs. The first thing to keep in mind is Atmel picoPower technology is in all these microcontrollers. We offer a variety of sleep modes. If you need just to have the CPU at idle, you can put it in idle mode. If you need the CPU to run just on a 32 kilohertz real-time clock, you can do that as well. Or you can put it all the way in the deep sleep mode where it will consume 100 nanoamps of power in power down mode. So really, depending on what your application is and your needs, you can really tweak where you need your power consumption to be and your performance. You can also adjust the frequency via software. So maybe in certain parts of the application you need to be running very fast. However, later on you're just doing some basic updating, some basic sequencing techniques, things like that. You can clock that frequency back down and run it at 1 megahertz or less. So that way you're not consuming that power consumption all the time. So taking a quick look at the power equation, as you see here, VCC is the biggest component, VCC squared. So the higher your power supply, the more power you're going to consume. So if we take a look at our micros, you can see they're down to 1.8 volt operation. So by reducing that power from the voltage from 3.3 down to 1.8, you really get an extended life on your product. You get a longer life, you get deeper discharge of batteries, and this is everything. Everything runs all the way down to 1.8 volt. They don't get anything cut off at higher than that. So it's a fully functional device at 1.8 volts. Our XMEGA introduced their 2nd generation picoPower. So this took the picoPower to the next level. We've added true 1.6 volt operation. So this allows you to run a 1.8 volt supply plus or minus 10%. That's again everything that we talked about on the mega AVRs and tiny AVRs. Everything runs down to 1.6 volt. And we still maintain the extreme low power 32 kilohertz crystal oscillator at 550 nanoamps. We've added a new low power watchdog and brownout detect so you can achieve 1 microamp in your power down mode. So very, very low power on these devices. And again, we keep the same clock switching, so if you need to run at high speed initially and turn it down or switch back and forth, you can do that. Also, you can change your clock sources, so if you want to run from the internal clock or the external crystal, you can switch that whenever you're needing your application. The next system that we added to the XMEG and also to our UC3 is the event system. And what the event system is, I like to think of it as a hardware routing layer. It allows you to, at startup, customize how you want your peripherals to communicate and work together. So if we take a quick look at the diagram over here on the right side, you see that if you have an analog comparator event occur, it can do something to the timer counter. It can increment the timer, decrement, it can turn off the PWM, things like that. So that is all done completely in hardware. So you don't have to worry about any software maintaining or updating anything. It's all done in hardware. And what does that also give you? It gives you safe fault protection and 100% predictable reaction time. So if you're doing code development and you're testing things out, sometimes you might have errors in your code. We're all not perfect. And if you do make mistakes like that, you can be assured that even though the code isn't executing, you may stuck off in the weeds somewhere, this is all done in the background in hardware. So always you have that safety protection behind the scenes. So it's a very, very nice feature on both our XMEGA and a lot of our 32-bit AVRs. So moving into our 32-bit AVR product line, we have the UC3L. Now this is the industry's lowest power consumption down to 0.48 milliwatts per megahertz, and that's executing actual code. We're actually working the pipeline, we're actually performing instructions, we're not stalling the pipeline or anything like that. So this is a true number of what you'll get on the power consumption. We also offer down to 1.5 microamps while running off the real-time crystal, real-time clock. The same deep 100 nanoamp shutdown mode, and a new technique which we call sleepwalking, and I'll show you that on the next slide. Another great feature that we've added is flash vault code protection. A lot of customers will have a design that they only develop a small part of. So they develop a couple K of code, maybe they have some kind of a filtering algorithm or something like that, and they want to deliver that to a third party. Typically you would take a library and you would distribute that to the customer and they would link that in. Well, now the customer has access to the binary information and it makes some people nervous about their protection of their IP. By enabling Flash Vault, you can take that code and lock it into a specific region into the UC3L. And by doing that, the customer can develop their code, they can debug their code, and your code is locked away and can't be read or used by them. So you can be assured that the IP is protected and safe. So it's a very nice design for anybody who's doing that type of work. So a little bit more in-depth look here at the sleepwalking technique. We'll take this as a normal situation where we have the system up and running. We've got a temperature thermistor going into the ADC, and we periodically need to check to see if there's an over temperature situation. So we put the part to sleep. You're running in power save mode with just the real-time clock executing, and you see nothing else is running. This is static mode. So you're at the very low 550 nanoamp power consumption, extremely low power. Periodically, the real-time clock will wake up the ADC and need to do some work. So in a normal situation, in a normal microcontroller, the entire processor wakes up. It has to perform all of these checks. So your CPU's running and you're really consuming a lot of power. By using this sleepwalking technique, only the ADC block wakes up. So the rest of the chip, the buses, the CPU, all that stuff that would be consuming power you don't need, stays asleep. So the real-time clock wakes up the ADC, and the ADC can qualify this event. So in this case, the temperature is below our threshold, and we can return back to sleep mode. So that means that nothing else actually woke up, just the ADC block, and we're back into static mode without consuming a lot of power. So the next time around, we have our ADC event. A couple times later, however it works, this time it wakes up and it says, the temperature is above the threshold. Now this signals the rest of the architecture, the CPU, the buses, and everything else to wake up, and you enter into normal mode. So by using this technique, you can qualify events on certain peripherals before you have to wake up the entire chip and consume a lot more power consumption. So I hope that gave you a nice overview of the picoPower technology that we have in both our 8-bit and 32-bit AVR families. If you have more questions, you can contact us here at Embedded System Conference, or we have online resources, plus a great community website, avrfreaks.net, and a lot of videos and trainings can be found at avrtv.com. So thank you all for joining today.